So what we're going to focus on here is the idea of the binomial distribution. When we talk about the binomial distribution, this is going to be based off a discrete random variable. And there are 4 requirements if we're talking about binomial distribution. The first is there must be only 2 possible outcomes. Typically we refer to these as success or failure. Could be heads or tails, male or female, but there's only 2 possible outcomes. When we start a distribution, we have a set number of trials. For example, I know that someone's going to take 15 free throws. I know I'm going to flip a coin 47 times. I have to establish right at the beginning how many trials I'm going to be looking at. We talked about 2 possible outcomes, success and failure. Well, the probability of each must remain the same. So if we know that a particular basketball player is an 82% free throw shooter, the probability of him or her making a free throw is 0.82. That has to remain the same throughout all of our trials. The probability of me selecting a king out of a deck of cards is 4 out of 52. Well, if I'm looking at it as a binomial distribution, that success would have to remain the same, so I would have to replace that card when I pulled more cards from the deck. And then all trials are independent of each other. What happened in the previous trial has nothing to do with what's about to happen. For example, a family has a boy, and the second child, whether it's a boy or a girl, is not affected by the fact that they have a boy for their first child. Now, there's a formula that goes along with this. And the formula talks about a little bit about combination. It takes this into account, this NCR idea. And then it's going to be the probability of success, which we'll call P, to the R power, and I'll give all these a label in a second. And you might see it as 1 minus P to the N minus R power. This could also be referred to as Q, and that's typically how I refer to it. So this is saying the same thing as you also see the formula written that way, where N is your number of trials, R is your number of successes, P is your probability of success, and then Q, because it's 1 minus P, will be the probability that you fail. For example, missing a free throw. If success would be getting ahead, then the probability of failing would be getting a tail. Well, let's talk about mean, standard variance, and standard deviation. Well, we just said that my N is my number of trials. And we said that P is the probability of success. Well, to find the mean, or the expected amount, all you're simply going to do is take your N value and multiply it by the probability of success. And we'll do an example in 1 second. To find my standard variance, you're going to take your N, multiply it by your P, and then multiply it by your Q. Remember, Q is the probability of a failure. And then standard deviation is just simply going to be the square root of the variance formula. So let's look at an example. 57.5% of registered voters chose to vote in the 2008 presidential election. If 20 registered voters are selected at random, what is the probability that only 8 voted? Well, in this particular case, my p-value is 0.575, probability of success, which means my q has to be 1 minus that number, so 1 minus 0.575. So my q value is 0.425. My n, my number of trials, is 20. My r, my number of successes, is 8. So when I go down to my formula, it's going to simply look like this. Now if you look here, I also could replace this with just simply the number 12 if I wanted to. This 8 talks about the number of successes that I expect and the probability that a success will occur. This 12 talks about the number of failures I would get, the number of people who did not vote, and the probability that someone did not vote. Then I would take this entire thing, put it in my calculator. I might suggest doing this by pieces as you go through so you don't screw up the order of operations. But once you put it in the calculator, what you will end up with is rounded to 2 decimal places. So the probability that if I select 20 voters in 2008, that 8 of them had voted, exactly 8, the probability of that having occurred is 0.05.